Okay guys, so today is going to be lesson 9.3, attributes and transformations of rational functions. So let's go ahead and begin. So we're going to go ahead and we're going to be talking about a rational function today. Okay, now the parent function for a rational function is going to be y equals 1 over x, where x cannot equal to 0. Because if you put a 0 for the denominator, then the function will not exist. It's going to give you an undefined value. So the denominator can never ever be 0, or it can never equal to 0. Not that it cannot be 0, but it cannot equal to 0. Okay, so we're going to go ahead and we're going to graph this function and come up with some values. I'm going to go ahead and I'm going to use -4, -2, -1, 0, 1, 2, and 4. So basically I'm just going to put the x values in for x. So then that's going to give me 1 over -4, 1 over -2, 1 over -1, 1 over 0, 1 over 1, 1 over 2, and 1 over 4. Well, positive divided by a negative is literally just going to be -1/4, -1/2, -1. Here I have a denominator of 0, which I said cannot happen. So this right here is going to give me undefined. You guys don't believe me? Plug it into your calculator and you'll see that it gives you 1. Undefined. 1 divided by 1 is 1. 1 over 2 is just 1 over 2. And then 1/4. So I'm going to go ahead and I'm going to graph these. So x is going to be -4, -1, -2, -3, -4. And then y is going to be at -1/4. So that'll be -1. So 1/4 will be right here. Right there. -2. And then that's at -1/2. -1/2 is like right there. Be right there. And then -1 goes with -1, so right there. And then I have 0. Well, 0 is undefined, so I'm not going to do anything there. Now I should probably use smaller values, but technically what's going to happen is that it's going to keep on going smaller and smaller here like this. And so you get something like that. And so then we continue with the other one. So now I'm going to have 1, 1. Which is right there. 2, 1/2, which would be half of that right there. And then 4, 1/4, which would be right there. And then the other ones are also just going to be replicated, just getting smaller and smaller as they get up. So if I connect the dots, I'm going to get something that looks like this. Okay, and that right there is what your rational function is going to look like. Okay, so now we're going to go ahead and we are going to talk about the key attributes. So obviously the first one that we have is domain. So because there are two parts to this graph, the left side and the right side, you're going to have two domain ranges in a way. So we're going to go from left to right. So I start at the left side and I have an arrow, right, which means infinity. Now, if I'm on the left side of the graph, that means that it's going to have to be negative. So I'm going to go from -infinity, and then I'm going to go to the boundary, which is going to be 0. Why? Because there I have something called an asymptote, okay? So here is going to show up my asymptote, okay? So that right there is going to be my asymptote. It's going to be my vertical asymptote, where x is going to equal to 0. So that means that my domain is going to be from -infinity to 0 with a parentheses because it's an asymptote. And then we go ahead and continue and jump to the other line, which is the right half, and that's going to continue from where we left off, which is the asymptote of 0 going all the way up to infinity. Okay, and so then we go on with the range. It goes from the bottom to the top. So the range is going to be from -infinity because you have an arrow there, and you're going to go all the way to the top to that asymptote, which is going to be at 0 as well. but this one is going to be horizontal. So that right there is going to be a horizontal asymptote at y equals to 0, because this is the range, right? So we're going to go from negative infinity to 0, and then we continue where we left off, so that's 0 going all the way up to infinity. Now, I just told you where your horizontal asymptote was, which was at y equals to 0. So the horizontal asymptote will always be y. Okay? And the vertical asymptote is going to be x equals to 0, meaning that this will always be x. Okay, now an x-intercept, well, in this situation, there is no x-intercept because I have an asymptote at the x-axis, right? So, which means this. So there is no x-intercept. Okay, because I have an asymptote literally at both 0. So that means no x-intercept. That also means that there is no y-intercept. Okay, and that right there will be the attributes for this function. So now we're going to go ahead and move on to the transformations. Now we're not going to be graphing this today, but I am just going to leave this here so you guys can sit on this thought. We will continue with this lesson tomorrow. Tomorrow's lesson is going to be a little bit more deeper and thorough than this one, so just keep that in mind. I just want you guys to sit on this idea. Okay, so the transformation of rational functions. We're going to have a negative. Okay, we have a negative right here, a, and the numerator. Now the denominators, we're going to have b and h. Okay, and then obviously this one right here is k. So the negative is going to tell us a reflection over the x-axis, which just means that it's going to look like this right here. A is going to be our vertical compression or stretching. Just keep in mind that this will always be in the numerator. Okay. And then you have B, which is horizontal stretching or compressing. This one will be in denominator. And in front of X. Okay, H is also going to be in the denominator. Oops, run out of space. Okay, it's going to be in the denominator, and that one tells you to go left or right. Remember, always do the opposite. And then K is just going to be outside of fraction. Okay, and so that's what these transformations would look like. Okay, so I'm going to leave it at that for today, and we will continue with this tomorrow.